Okay, for chapter 1 kinetic particle theory, basically you need to know very clearly about the arrangement of particles, particle motion, how the particles move, attractive forces between particles, as well as kinetic energy of particles for the 3 states of matter. Okay, so this question usually is in the form of, for example, explain using kinetic particle theory, blah blah blah. So if it says explain using kinetic particle theory, means that you have to explain the particles, what happened to the particles. This is an example of one such question. Why can gas be compressed? So you don't give a general statement as in, for example, solid cannot be compressed. So you have to explain what happened to the solid particles if it cannot be compressed. So in this case, you have to explain what happened to the gas particles inside the gas that enables it to be compressed. Then you need to know the names of the different change of states. Okay, sublimation, for example, sublimation, condensation, freezing, melting, etc. This one you have learned it in lower sec, but it would not hurt for you to revise it again here. Then you need to know the difference between the boiling and evaporation. So basically boiling only happened at the boiling point, and evaporation at temperatures, basically evaporation is at all temperatures below the boiling point, more specifically at any temperature below the boiling point. Okay, the second page is about the heating curve and the cooling curve. So typical questions on this would be, for example, they give you the heating curve for water. Okay, so as water is heated, for example, the question says, explain using kinetic particle theory for water when it is heated from 25 degrees Celsius to 125 degrees Celsius, for example. So you have to explain at 25 degrees Celsius what happened to the particles in the water, and then when it reached 100 degrees Celsius, what happened, and then after that at 125 degrees Celsius, what happened. So there are actually 3 stages: at 25 degrees Celsius, at 100 degrees Celsius, which is the boiling point of the water, and at 125 degrees Celsius, which is after the boiling point. So you have to explain at each stage what happened to the particles in the water. Okay, what are the things to touch on? That would be the arrangement of particles. That will be the previous page. Arrangement of particles, particle motion, attractive forces, and kinetic energy. Sometimes the question will say, explain from the point of view of arrangement of particles. Then you only have to mention the arrangement of particles. Okay, likewise for the cooling curve. So over here basically details what happened when the liquid freezes and after it has frozen. So that's all about chapter 1, kinetic particle theory. Now for the second chapter, measurement and experimental techniques, you need to know, basically you need to know the differences between the different apparatus for measuring in the chemistry lab. So for burette usually the accuracy is up to 0.1 cm3. So you can measure up to, for example, 24.7 cubic centimeter. For pipette, pipette is a fixed volume, either 20 cm3 or 25 cm3 for pipette. For measuring cylinder, usually it's up to the accuracy of 1 cm3. So for example, you can measure up to, for example, the 34 cm3. You cannot have like 34.1 cm3 or 34.2 cm3. So in order to get such measurement, you need a burette. Then for the second page of the measurement and experimental techniques, Basically, this part concerns the different methods for collecting different gases. Now, these are the three different methods for collecting gases in chemistry lab. Displacement of water. So basically, you collect the gas using this delivery tube, and then after that, it would force the water down. This is displacement of water. You have downward delivery, you have upward delivery. So which method to use depends on two properties of the gas. So you have to look at the solubility of the gas as well as the density of the gas. Solubility of the gas. If let's say the gas is soluble in water, of course it cannot be used. Of course you cannot use this displacement of water method to collect it. Otherwise the gas would dissolve in the water and then you collect nothing. So if the gas is soluble in water, you cannot use this method. You can either use this or this. Now, which one of these two should be used, that would depend on the density of the gas. If the gas is very dense, meaning that it is heavier than the air, then that would be the downward delivery. So if let's say the gas here is very dense or very heavy, so it will be collected at the bottom half of the jar, of the gas jar. If the density of the gas is less than that of air, then it should be collected using this method, because if the gas is light, it would tend to float at the top part of the jar here. Okay, so this part, so the which method to collect gas depends on the solubility as well as the density. And for gases, usually we collect it using gas syringe. Now the last part here is about how do you dry gases that you collect in chemistry lab. So many times, most often, very often we have to dry the gas that we collect. So how do you dry the gas? You can either use concentrated sulfuric acid, quicklime, or calcium oxide. See, another name for calcium oxide is quicklime. Calcium hydroxide, that will be slaked lime, SLAKED. Slick lime, that one is calcium hydroxide. And then you can also use calcium chloride, fused calcium chloride. Fused means previously heated. Now for this, for drying of gas using sulfuric acid, the gas to be dried cannot be alkaline. So for example, NH3, and NH3 is alkaline. Okay, NH3, the ammonia gas, would turn moist red litmus paper blue. So your NH3 is an alkaline gas. So you cannot dry NH3 using concentrated sulfuric acid, because alkaline acid, they will react. So if you collect NH3, if you dry NH3 using H2SO4, at the end of it you get nothing. The NH3 will disappear because the NH3 will react with H2SO4 to give you salt and water. So the other two methods would have no such restriction. You can use this any of these two methods to dry any gas. Okay, the third chapter is on purification and separation. So basically you need to be aware that the presence of impurities will cause the melting or the boiling point to be in a range. For example, the melting point of benzoic acid is 122 degrees Celsius. If there is impurity present in the benzoic acid, then the melting point will not be 122 degrees Celsius. Instead, it would melt over a range of temperature. Likewise, for water, for boiling point, it will boil over a range of temperature if there is impurity present. And for melting point, the effect of impurities is the presence of impurities will lower the melting point, and the presence of impurities will increase the boiling point. That is the effect of impurities on melting point and on melting point and boiling point. Okay, then for chromatography, you need to know that chromatography uses the principle of solubility to separate the substances in a compound. Okay, so for example, a dye which is not very soluble would travel a short distance. Okay, this one should be a short distance. And a dye which is very soluble would travel a long distance. So chromatography uses solubility. So the distance that a particular dye travels in the chromatogram depends on the solubility of the dye in the solvent that is used in the chromatography. Let's say you have one spot. It means that this particular dye is pure because it only has one substance. So in this example here, A and D are pure substance because they only have one spot each in the chromatogram. For separation technique, okay, these are the different separation techniques. So for each separation technique, you need to know what principle do they operate on. More importantly, you need to know simple distillation. So simple distillation basically is for separating a solid which dissolves in a liquid. A very good example would be separating salt from the salt solution. You use simple distillation. For fractional distillation is to separate mixable liquids. If you have two or more liquids which can mix together, then in order to separate them you have to use fractional distillation, and it basically operates on the principle of different boiling point of the different liquids. So the different liquids must have different boiling points in order for them to be separated using fractional distillation. And this is how the different parts of the fractional distillation work. So you need to be very familiar with them. And then for separating funnel, basically is to separate two liquids that don't dissolve, that are not mixable in mixable liquids. So for mixable liquids, you use fractional distillation. In mixable liquids that don't mix together, for example, oil and water don't mix together. So in order to separate them, you need to use separating funnel. And these are the steps. The next chapter is elements, compound, and mixture. Now for this chapter, you need to be very clear with the definition. So you need to know the definition of elements. A pure substance. Elements basically is a pure substance. It can't be decomposed into simpler substances by chemical process. As well as the compound. What is the definition? Definition for elements and for compounds. Now compounds is also a pure substance. Doesn't mean that compounds is not pure. So this is a major misconception. Also, you need to know that the different properties of compound. Okay, different properties of compound in terms of spec, separation, properties, energy, and composition. Now, usually the questions would ask you to differentiate mixture and compound. So you have to be able to recall what are the differences between mixture and compound in terms in what kind of properties. So this table detail the difference between mixture and compound. So you just try to recall spec, separation, what is the difference, properties, what is the difference, energy change, what is the difference, and composition, what is the difference. And also you need to be able to tell from the model diagram. These are the particulate model diagram. Okay, the difference between elements, compound, and mixture. And one thing to take note is alloy. Alloy is not a compound. Alloy is a mixture. Same thing with Milo drink. It's also a mixture. Okay, the next chapter is on atomic structure. So for this chapter, first of all, you need to know the definition of isotope. Remember, definition of isotope, there are two parts. Not just same number of protons, different number of neutrons. It's not just that. You have to know that it is atoms of the same element, because isotopes must come from the same element. Example is chlorine 35 and chlorine 37. These are the two isotopes for chlorine, and both of them belong to the same element, which is chlorine. So when it comes to the definition of isotope, make sure you have atoms of the same element, and then after that, that is the first pointer. The second point will be same number of protons with different number of neutrons. An atom, you need to know that the word atom basically implies that the charge is neutral. Charge is neutral basically implies that the number of protons and the number of electrons are the same. Okay, so this table will tell you the charges of the proton, neutron, and electron. These are the subatomic particles in the atom. That means what are the things inside the atom? The relative mass. Remember, this is not mass, therefore there is no unit. Relative mass and the symbol. And of course, you need to know in the periodic table, these two numbers, what do they mean? The top number basically is the mass number or nucleon number, which is the number of protons and neutrons added up together. The bottom number is the atomic number or the proton number, which is basically the number of protons. So for an atom, the number of protons and neutrons are the same. If it is ions, their number of protons cannot be the same with the number of electrons. So these two numbers, you have to be very clear what they represent. And of course, at the top of it, there will be the examples of isotopes. Okay, take a good look at the at these two examples. And basically, isotopes, they have the same chemical properties but different physical properties. They have the same chemical properties because they have the same number of electrons. Remember, the number of electrons, number of valence electron in particular, determines the chemical properties. Okay, and the rules for filling up the electron shells. First shell can hold up to a maximum of 2 electrons, and the subsequent shell 8 electrons. Valence shells means the outer shell. Valence shell is the most outside shell. See, the valence electron, this part is very important. Valence electron is the electrons in the valence or the outer shell. It determines the chemical properties. So if two elements, they have the same number of valence electron, means that they have the same chemical properties. For example, sodium and potassium, they are in group 1. So all the elements in group 1 have the same chemical properties. Why? Because they have the same number of valence electrons.